We're also going to look at sequences in this unit. And I wanted to make sure we went over this because sometimes this is covered in previous courses and sometimes it's not, depending on time. But a sequence is just a ordered list. It's numbers that have a pattern. So we're looking at patterns for a second. So let's say we're going to write out the first 4 terms of the sequence that follows this pattern. So, in other words, n is the position, the position it's in. So the first one, a sub 1, would be my first term. So I'm going to plug 1 in for n. And I'd have negative 1 to the first power divided by 2 times 1. That's going to give me negative 1/2. The second term, I'm going to be plugging in 2 for n. And so this would be a positive 1 over 2 times 2, which is 4. The third term, I'm going to plug in 3 for n. So negative 1 cubed would be negative 1. So this would be negative 1 over 6. And the fourth term would be negative 1 to the 4th over 2 times 4. So that would be a positive 1 over 8. So you see how we get this pattern going. It's negative 1/2, then positive 1/4, then negative 1/6, then positive 1/8. And once you see the pattern, you wouldn't really have to plug in again, because the next term would be negative 1/10, then positive 1/12. Now there's special sequences, and one special one is called an arithmetic sequence. So if we look at this sequence, 2020, 2040, 2060, 2080, 2100, it starts, the very first term is 2020, and each additional term is found by taking the previous term and adding 20 to it. What we're adding is called a common difference and is usually represented by a D. So this means the previous term and this means the current term. So let's just see if we can notice the patterns real fast. So 1, 3, 5, we're adding 2 each time, so the next 3 terms would be 7, 9, and 11. This one is going down by 3, so the next term would be 0, then negative 3, then negative 6. Ooh. Well, this is a pattern, and it may actually help to rewrite 1/2 to have the same denominator. This would really be 3/6, 5/6, 7/6. So I'm adding 2/6 each time. So the next term would be 9/6, and then 11/6, and then 13/6. I can't say sixth. Now, another way to write an arithmetic sequence is using this formula. And it says that I can find any term by taking the first term plus the position minus 1 times D, that common difference. So let's say we want to find the 11th term. So we're trying to find A sub 11. Using this formula, we need the first term, which is 3, n minus 1, which would be 11 minus 1, times the common difference of negative 2. Now you could have started with 3 and then subtracted 2 each time until you got to the 11th term. You could do that. There's no problem with doing that. It just is time consuming. So this would be 3 plus 10 times negative 2. That's a negative 20 plus 3. That would be negative 17. If the first term of an arithmetic sequence is 4, and the ninth term is 20. Find the 75th term. Oh, so we got to look a couple of steps here. So we've got a sub 1 is 4. The ninth term is 20. So a sub 9 is 20. And we're trying to find a sub 75. And I would not want to write that all the way out there. But we don't even know the common difference yet. But we can find it using this information. So 20 would be found by putting 9 in for n. So it would be taking the first term plus 9 minus 1 times the difference. I'm going to go ahead and subtract the 4, and that gives me 16 equals 8 times d. So d is a positive 2. It's going up by 2 each time. Now I can find that 75th term. It's the first term plus the position we want minus 1 times that common difference. That's a lot easier to work with, right? So 4 plus, that'd be 74 times 2. Now we can also find the sum of an arithmetic sequence. And there is a formula for that as well. We would take the first term plus the last term of a certain number of terms, and then the number of terms divided by 2. So the first 10 terms of an arithmetic sequence, with the first term being 2, and the common difference is 4. So to be able to use this formula, I need the 10th term. So we need to find a sub 10 to use this formula. So we'll use the formula from above. 2 plus 10 minus 1 times 4. Now that I have the 10th term, I can find the sum of the first 10 terms. The formula says the number of terms divided by 2, then the first term plus the last term. So that gives me a 40 times 5 is going to be 200. What if we were asked to find the first 91 terms of, and I forgot to write it in, this should be 1/4, then 7/12, and then 11/12. Sorry about that. Okay, so if we want to find the first 91 terms, we know the first term. But what's the common difference here? Well, we're adding 5/12 each time, because this would, no, 4/12, because this would be 3/12. So we're adding 4/12. So D is going to be, and I might leave it as 4/12. It might just be easier. Or we could write it as 1/3. We're going to be putting it in the calculator anyway. And if I want the first 91 terms, then I need the 91st term. So I'm starting with 1/4 plus 91 minus 1 times 1/3. And I'm going to go ahead and find that. 1/4 plus 90 times 1/3. Oh, that's going to just be 30, isn't it? 30.25. So the sum of the first 91 terms is going to be found by taking 91 divided by 2 the first term plus the last term. So 91 divided by 2, parentheses, 1/4 plus 30.25. And we get 1,387.75. A lot faster than adding up 91 fractions.